Today we will discuss about chemical properties of haloalkanes. First is substitution reactions in haloalkanes. Substitution reaction. It is of different types as below. These are discussed below. First is reaction with aqueous alkali. Aqueous alkali. Alkali, what is alkali? Strong bases are called alkali. Strong bases are called alkali. Alkalis are like NaOH, KOH. Aqueous alkali means alkali or KOH dissolved in water. KOH dissolved in water is called aqueous alkali. Example 1 is C2H5Br, C2H5Br bromoethane or ethyl bromide, aqueous alkali. This Br minus is replaced or substituted by OH minus. This K is plus, OH is minus. So this is nucleophile. OH minus is nucleophile. This nucleophile is substituted by Br. So it is called substitution nucleophilic or nucleophilic substitution reaction. Nucleophilic substitution reaction. So we get C2H5OH plus KBr. C2H5OH plus KBr. These reactions are very simple. You can remember easily. Then example 2, iodoethane. I. Aqueous AgOH. AgOH will get C2H5OH plus AgI. AgOH, Ag is very often used because AgCl, AgBr, AgI are easily precipitated. So they can be removed easily. Cost of product will be less. So C2H5I plus aqueous AgOH will give C2H5OH ethanol plus AgI. AgI silver iodide is precipitated. Example 3, 2-bromopropane. 1, 2, 3. 2 position bromo is attached to second carbon, so it is called 2-bromopropane. 2-bromopropane plus aqueous KOH will get propane 2-ol. Propane 2-ol plus KBr. So these are the nucleophilic substitution reaction. Also I will discuss it vividly later, as it is in our course mechanism will be given. It is of two types. One is SN1 reaction and another is SN2 reaction. Substitution nucleophilic unimolecular, substitution nucleophilic bimolecular. I will go through the mechanism of these two reactions again after the chemical. Nucleophile is OH minus. Nucleophile is OH minus. Then we will go to second reaction, that is Williamson's reaction or reaction of alkyl halide with sodium alkoxide. Sodium alkoxide means RON, sodium alkoxide. RO minus is called alkoxide. This is nucleophile. RO minus is nucleophile. RX plus RONA, NX will go out, and ROR. ROR, this is general formula of ether. Example 2, this is a general reaction. We will go to particular reaction. Ethyl bromide plus sodium ethoxide. C2H5O. This is second carbon, 2 carbon, so it is termed as ethoxide. If it will be 1 carbon, it will be termed as methoxide. So C2H5O, that is called ethoxide. Ethyl bromide plus sodium ethoxide. Ethyl bromide plus sodium ethoxide will give diethyl ether. C2H5O, C2H5 plus NaBr. Diethyl ether or ethoxyethane. Ethoxyethane is the common name. Ethoxyethane is the IPS name. Diethyl ether is the common name. Next is example 3, methyl iodide. C2H5O, sodium ethoxide will get CH3O, C2H5. Methoxy, this is methoxyethane. Methoxy is attached to ethane or methyl ether. It is common name, it is IPS name plus NaI. Example 4 is C2H5Br plus C tertiary butoxy group, sodium tertiary butoxy. So we will get C CH3 O will get CH3, C, CH3, 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 O, C2H5. Ethyl tertiary butyl ether. Ethyl tertiary butyl ether. This is sodium tertiary butoxide. Sodium tertiary butoxide. So you should always name this reactant and product below. Otherwise reaction is not complete. You will not get good marks in exam. Always write the name below the reactants and also the products. Here nucleophile is RO minus, like C2H5O minus, CH3O minus. Next we will go to reaction with cation. Reaction with cation. Potassium cyanide. Cation is potassium cyanide. K plus Cn minus. Cn minus is nucleophile. Cn minus is nucleophile. When alkyl, do you know what is nucleophile? Nucleus loving. Nucleophile means nucleophile. Nucleophile means nucleus loving. You have taught, you have read it in faster still then. Means positive loving. Positive loving. Positive loving means negative ion. Like OH minus, Cl minus, NH2 minus. These are negative ions. Nucleophile. Nucleophile. Also molecules like water. Water has a lone pair. Oxygen, NH3. Nitrogen has a lone pair. So these are also nucleophile. These are neutral nucleophile. These are negative ion nucleophile. So concept of nucleophile should be clear with you. When alkyl halide reacts with alcoholic solution of cation, that means cation is dissolved in alcohol. Cation is dissolved in alcohol. Alkyl cyanide or nitriles. Alkyl cyanide is common name, nitriles is IPS name are formed. Cn minus is the nucleophile. So we will go to the reactions, in particular reactions. So in particular reactions, first is example 1, CH3Cl, methyl chloride or chloromethane plus cation alcoholic. You can also write it here, alcoholic. CH3C triple bond. Cn means C triple bond. C triple bond, it is 1 sigma bond, 2 pi bonds. 2 pi bonds plus cation. Ethane nitrile, 2 carbon. 2 carbon, so IPS name is ethane nitrile. Ethane nitrile or common name is methyl cyanide. This is methyl cyanide. So common name is methyl cyanide. IPS name is ethane nitrile. Ethane nitrile. Second example is C2H5Br bromoethane plus cation alcoholic. C2H5Cn plus KBr. Ethyl cyanide, common name. Propane, 3 carbon. 2 plus 1, 3 carbon. Propane nitrile. Propane nitrile. So the importance of this reaction is these cyanides can give other products on oxidation and reduction. Ethane nitrile or methyl cyanide on oxidation, that is in presence of water, acidic medium, will give CH3COOH. CH3COOH, acetic acid plus ammonia. This will give ammonia, this will give acetic acid. Reduction will give CH3CH2NH2. CH3CH2NH2. I have explained it. How does it occur? CH3C triple bond N. CH3C triple bond N. N is delta minus, carbon is delta plus, because nitrogen is more electronegative. Nitrogen is more electronegative than carbon. So positive ion will go to electronegative and negative ion will go to less electronegative or delta plus. So H plus will go to nitrogen, OH minus go to carbon. H plus OH minus, H plus OH minus, H plus OH minus. So it will give CH3C, 3 OH are attached to carbon and ammonia. But when 2 OH or 3 OH are attached to carbon, 1 carbon are attached to 1 carbon, it becomes unstable. It becomes unstable. So water is eliminated. Water is eliminated. Water is eliminated, so that we will get CH3, C double bond O, single bond OH, or acetic acid. So this is a gradation reaction. Carbon number will increase. Carbon number will increase in this reaction. Similarly in reduction, CH3, C triple bond N, H, sigma bond will not break. Pi bond will break. So this is one addition reaction. H, when pi bond breaks, it is called addition reaction. So we will get CH3, CH2, NH2. CH3, CH2, NH2. It is 1 degree amine. 1 degree amine, ethylamine. 2 carbon, ethylamine. Next reaction is reaction with AgCN, silver cyanide. AgCN means silver cyanide. Silver cyanide will give different product than that of the KCN, potassium cyanide. Silver cyanide will give different product than that of potassium. What is the product here? Rx plus AgCN. Rx plus AgCN will get RNC. RNC plus AgX. AgX is precipitate. Alkyl isocyanide. It is termed as alkyl isocyanide. These are termed as cyanide. Cn is cyanide. NC is termed as isocyanide. Alkyl isocyanide. This is a sigma bond. This is pi bond. And this is coordinate bond. Relative bond or coordinate bond. So it is more reactive than cyanide. As it is a coordinate bond. So it is more reactive than cyanides. So example 2 is methyl bromide or bromomethane. Bromomethane. IPS name or common name is methyl bromide plus AgCN silver cyanide will give CH3NC, methyl isocyanide. Methyl isocyanide plus HgBr. HgBr is precipitate. C2H5Br, ethyl bromide plus AgCN will give C2H5NC. C2H5NC, ethyl isocyanide plus HgBr. So, as in case of cyanide, we have read about the oxidation reduction. So also we will read about oxidation and reduction here also. So, CH3NC, methyl isocyanide. On oxidation, will give CH3NH2. Bond will break here. It will be acidic. It will be amine. CH3NH2 plus HCOOH, formic acid. HCOOH, that is formic acid. On reduction, that is hydrogen nickel. Or and other reducing agents are also, we will discuss after this. CH3NC, it will give CH3NH, single bond CH3. CH3NH, single bond CH3. This is dimethylamine, 2 degree. In case of cyanide, we have got 1 degree amine. In case of isocyanide, on reduction, we got 2 degree amine, dimethyl, 2 methyl groups, dimethylamine. So this is the method of preparation of acid. Also this is the method of preparation for amine, 1 degree amine, 2 degree amine. In amine chapter we will read this. In acid chapter we will also refer this. So these reactions are very important, base reactions. Also during conversion we will go through these reactions. So now I will explain you what is the reason for 2 types of products. Here we got 2 types of product. One is cyanide, another is isocyanide. What is the reason behind it? The question may be asked about it. KCN is an ionic compound. That means K plus Cn minus. Cn minus, negative charge is over carbon. Negative charge is over carbon, it is nucleophile. So C minus will attack to carbon. C minus will attack to carbon, Br minus will attack to K plus or KBr, CH3Cl. Do you understand? So this is a ionic compound, negative charge is over carbon. But AgCN is a covalent compound. AgCN is a covalent compound, AgC triple bond N. So this bond is not easy to break. This bond is not easy to break. Rather, lone pair above nitrogen will attack as nucleophile. I have told you, ammonia is a nucleophile, lone pair will act as a nucleophile. So this will attack the carbon. Br minus will attack to silver. So we will get CH3NC. CH3NC plus AgBr. Here C triple bond N lone pair is nucleophile. Do you understand? So what is the reason for two types of product? This is very important. Next is reaction with KNO2. Reaction with KNO2. KNO2 means potassium nitrite. Potassium nitrite. KNO2 is ionic compound. K plus NO2 minus. NO2 minus I have splitted it. O single bond N, double bond O. Oxygen is divalent, nitrogen is trivalent. This is negative charge, so monovalent. So negative charge is over oxygen, not over nitrogen. Why? You can ask why? Because oxygen is more electronegative than nitrogen. Oxygen is more electronegative than nitrogen. So oxygen carries the negative charge. Oxygen carries the negative charge and it will attack the carbon as nucleophile. Methyl bromide plus minus, C is plus, so O minus will attack to carbon. CH3O double bond O, so that is CH3O N double bond O methyl nitrite plus KBr. Ethyl bromide plus KNO2. NO2 I have split it as you can understand it better. Not in this manner but in this manner. You can understand it better. It will be easier for you to write it. So O minus will attack the carbon. CH3 CH2O N double bond O means ethyl nitrite. Plus KBr. But it is different for AgNO2. As in Ca and AgCN, it is also different for AgNO2. Silver nitrate. In potassium nitrate, it is silver nitrite. Nitrate means NO2 minus, nitrate NO3 minus 1. AgNO2 is a covalent compound. AgNO2 is a covalent compound. AgON double bond lone pair. Nitrogen has lone pair. This lone pair will attack the carbon as nucleophile. Oxygen has also lone pair, but oxygen will not attack. Why? It may be asked in question. Why oxygen will not attack, rather nitrogen will attack? Oxygen is more electronegative. Oxygen is more electronegative than nitrogen. That means, what do you mean by electronegative? Tendency to attract the shared pair electron more towards itself. So as it is tendency to attract the electron more towards itself, it has less tendency to donate electron. But it is not more electronegative, or in other words, we can say it is less electronegative, means it has more tendency to donate the lone pair. So nucleophilicity of nitrogen, in chemistry language we will say that nucleophilicity of nitrogen is more than that of oxygen. Nucleophilicity of nitrogen is more than that of oxygen. Here nitrogen attacks carbon because it is less electronegative than oxygen. So its nucleophilicity tendency to donate electron is more. Example 1, CH3Br, AgO double bond O, nitrogen will attack CH3N double bond O, coordinate bond O, nitromethane. This is nitro group. This was a nitrate group. Nitromethane plus AgBr. plus HBr. C2H5Br plus HNO2, C2H5NO2 plus HBr plus HBr, nitroethane. Ethyl bromide, nitroethane. Next substitution reaction is ammonolysis or reaction with ammonia. Reaction with ammonia. Ammonia is dissolved in alcohol. Ammonia is dissolved in alcohol. There is a reason why, but it will be difficult for you, so I am not explaining it. Ammonia is dissolved in alcohol and reacts with alkyl halide at high pressure. At high pressure in a closed chamber, there may be high pressure, and ammonia reacts with alkyl halide at high pressure. So we get amines. Here mixture of products containing 1 degree, 2 degree, 3 degree amine and quaternary ammonium salts are formed at a time. In reaction container, 4 products are formed. So step 1, C2H5Br plus ammonia. I have written it as this because HBr will be eliminated and NH2 will be substituted. NH2 group is substituted in place of Br. In place of Br minus, NH2 minus. H plus will go, Br minus H plus HBr, NH2 minus will attack Br. So nucleophilic substitution. NH2 minus will be here. C2H5Br is NH2, C2H5NH2 plus HBr plus HBr. This is ethanamine, IPC name or 1 degree amine, or common name is ethylamine. So this reaction occurs in alcohol, generally ethanol. Alcohol. C2H5Br, C2H5NH2 will be C2H5NH. Nitrogen trivalent, 2 halides, alkyl groups are attached. NH, HBr. So it is called diethylamine. Diethylamine or 2 degree amine. This is first 1 degree amine, first step 1 degree amine, second step 2 degree amine. In third step, C2H5NH, this C2H5NH will again react with C2H5Br. C2H5Br ethanol, C2H5N plus H. This is triethylamine. Triethylamine or 3 degree amine. In fourth step, this triethylamine will also react with ethyl bromide, give tetraethyl ammonium bromide. It is termed as tetraethyl ammonium bromide or quaternary ammonium salt. This is like NH4. We are very much acquainted about NH4Cl, ammonium chloride. In ammonium chloride, ammonia is attached to H plus by coordinate bond and these are by ionic bond. So 3 types of bonds are present here. In ammonium, there may be a question, give an example of a molecule. In which 3 types of bonds are present. This is example of ammonium chloride. Here covalent bond is present, coordinate bond or dative bond is present, also ionic plus minus, that is ionic bond is also present. Ammonium chloride. In place of 4H, 4 ethyl group are replaced. 4H, 4. So it is called tetraethyl ammonium chloride, bromide. This is bromide. Tetraethyl ammonium bromide. So this is the salt, quaternary ammonium salt. This is not a suitable method for preparation of amine as mixture of 1 degree, 2 degree, 3 degree salts are formed. So this cannot be separated easily. So it is not a suitable method. But if C2H5Br or alkyl halide is taken very less, because alkyl halide reacts further. If alkyl halide is taken is in very less amount, and ammonia is in excess, only primary amine is formed. Ammonia is excess but alkyl halide less, In that case, 1 degree amine is formed. But if equimolar mixture of alkyl halide and ammonia will be taken, 4 products will be formed. 4 products will be formed. This is the Hoffman ammonolysis reaction or ammonolysis reaction. Also, we will read it in case of amine chapter. In amine chapter, we will also read it. All these reactions will be read in further chapters. The reaction with sodium bisulfide, NaSH, bisulfide or sodium hydrosulfide. Rx plus NaSH will give RSH plus NaX. Or C2H5Br plus NaSH, sodium bisulfide, will give C2H5SH plus NaBr. C2H5SH is called ethyl thioalcohol. C2H5OH, C2H5OH was C2H5OH is ethanol, but in place of O there is S, so it is called ethyl thioalcohol. It is called as ethyl thioalcohol. Formation of thioether. Formation of thioether. This is thioalcohol. We will now read about formation of thioether. C2H5Br, CH3SNA. In previous reaction we have read out CH3ONA. It is SNA. SNA. Sodium methyl mercaptide. We will get CH3S, CH3. CH3S, CH3 dimethyl thioether. Dimethyl thioether plus NaBr. C2H5Br, C2H5SNA, C2H5S, C2H5 diethyl thioether. Diethyl thioether. Reaction with silver salt of acid. Reaction with silver salt of acid or formation of ester. In ester chapter we will also read it. In ester chapter we will also read it. CH3COHG, silver acetate plus C2H5Br, ethyl bromide, will get CH3COO, C2H5. AgBr will be precipitated. CH3COO, C2H5. CH3COO, C2H5 is termed as ethyl acetate. Ethyl acetate or IPS name is ethyl ethanoate. Ethyl ethanoate. Next reaction will go to elimination reaction. Will go to elimination. Dehydrohalogenation of alkyl halide. Minus HX. Means HX will go. H will go here, Br will go here. It occurs in presence of alcoholic KOH. Substitution reaction occurs in presence of aqueous KOH. Elimination reaction occurs in alcoholic KOH. CH2 double bond CH2 plus HBr. This will give H, this will give Br, HBr. This HBr will react with KOH to give KBr plus water. KBr plus water. When bromoethane reacts with literature is given, then example 2, it is 2-bromobutane. It is 2-bromobutane. Here two types of possibility are there. It is alpha carbon, this is beta carbon, this is beta carbon. These are called beta elimination because hydrogen is eliminated from beta carbon. Br is attached to the carbon, this is called alpha carbon. Nearby carbon or neighboring carbon or adjacent carbon are called the beta carbon. Here two types of H can be eliminated from here or H can be eliminated from here. Which is the more possible pathway? This is according to Sorjev rule. This is according to Sorjev rule. Sorjev rule says that when alternative exists in beta elimination, more substituted alkene is the preferred product. More substituted alkene is the preferred bond. That means double bond, if double bond is attached to more alkyl group, it is called more substituted alkene. Here double bond is attached to two alkyl group. Here double bond is attached to only one alkyl group. So it is more substituted, it is less substituted, it is more stable. This can be explained by hyperconjugation. This can be explained by hyperconjugation. We have read about hyperconjugation in first year. So it is more stable and percentage of this product is more. So if double bond is here, it is called but2Ne. But2Ne. Hydrogen is eliminated from here, double bond will be produced here. This is but2Ne 80%. If hydrogen is eliminated from here, double bond will be here. It is called but1Ne 20% plus KBr plus water. Here 2 beta hydrogens are present. It occurs through Sorge route. So more substituted alkene is the preferred product. It is more substituted and it is less stable. Hyperconjugation. This but2Ne can have also 2 geometrical isomers. Can have also 2 geometrical isomers. Cis but2Ne, trans but2Ne. Cis but2Ne, trans but. This is trans. This is cis. So trans is more stable. So its percentage will be more than that of the cis. Another reduction of alkyl halide. Another is reduction of alkyl halide. Alkyl halide can be reduced to alkane. Alkyl halide can be reduced to alkane. Reducing agent of different types. Reducing hydrogen plus nickel is a reducing agent. Zn plus HCl, Zn plus alcohol, Na plus alcohol, Hi plus red fire, all these are reducing agents. Why? Because here hydrogen will be given. Here Zn plus 2Cl 2H. ZnCl2 plus 2H. This H is called nascent hydrogen. H is called nascent hydrogen. Nascent means newborn. It is produced in the container only. It is not stable outside. It is not stable outside the container. It is produced at this container only and it will react at once. This nascent hydrogen is an active reducing agent than molecular hydrogen. This is molecular hydrogen. This is nascent hydrogen, atomic hydrogen, nascent hydrogen. So this nascent hydrogen is more reactive than molecular hydrogen. So reduction occurs C2H5Br plus H2 nickel heat C2H6 plus HBr. C2H6 plus HBr. C2H5Cl plus 2H, Zn alcohol, ZnHCl, C2H6 plus HCl. CH3I plus Hi, red phosphorus, CH4 plus I2. Then we will go to reaction with active metal. Active metals, so those are more reactive. CH3I plus 2Na plus ICH3, you have also read it in alkane chapter. CH3 single bond CH3 plus 2Na. Iodomethane, when 2 molecules of iodomethane reacts with methyl metallic sodium in presence of dry ether. Dry ether is the solvent. Ethane and NaI are formed. Similarly, if different alkyl halide are taken, it is same alkyl halide. If different alkyl halide are taken, iodomethane, this is iodoethane. It will give 3 products. CH3I will react with CH3I. C2H5I will react with C2H5I. CH3I and C2H5 will react each other. So CH3 single bond CH3, C2H5 single bond C2H5, CH3 single bond C2H5. So CH3 single bond CH3 will give ethane, CH3 single bond C2H5 will give propane, C2H5 single bond C2H5 will give butane. 2 carbon, 3 carbon, 4 carbon. So these mixtures of ethane, propane, butane are formed and these are not easy to separate. So this is not a very important reaction. This reaction is not very important reaction. Reaction with zinc. It will also give C2H5 single bond C2H5 plus ZnBr2. C2H5 single bond C2H5 butane, 4 carbon, ZnBr2. This is called Franklin reaction. Another is reaction with magnesium. Important. Reaction with magnesium. This is very important. C2H5Br plus magnesium, metallic magnesium in presence of dry ether solvent will give C2H5 MgBr. C2H5 MgBr, ethyl magnesium bromide. It is called Grignard's reagent. Grignard's reagent is RMgX. This is Grignard's reagent. R means alkyl group or maybe aromatic. Magnesium, this is halide. Alkyl magnesium halide. Grignard's reagent. Victor Grignard prepared it in the year 1900. He won Nobel Prize for this in 1912 because it is used as a synthetic. From this, other organic compounds can be prepared easily. So it is called synthetic reagent. reaction is lead plus Na, C2H5Cl plus PbNa alloy, C2H5 whole 4 Pb. This is called tetraethyl lead, tetraethyl lead plus Pb plus 4 NaCl. Tetraethyl lead is an anti-knock compound. This is used. This was used in petrol to hinder the knocking property of petrol. Hinder the knocking property. Knocking means petrol will break into small parts. Long chain will break into small parts, so that its fuel value or calorific value will decrease. So it was used as anti-knock compound. Tell. Use of alkyl halide. From alkyl halide, alcohol, amine, ester, ether can be prepared. These are used as methylating agent. From alkyl halide, Grignard's reagent is prepared. So these are the preparations, chemical properties, and use. In next class, we will read about nucleophilic substitution reaction, SN reaction, and optical activity. First, we will read about optical activity, then nucleophilic substitution reaction. Then we will go to haloarenes. These reactions are very important. You should remember all these reactions.